So how about we go ahead and get started? So good morning, good afternoon, and good evening, everyone, depending on where you're joining us from. And welcome to the 42nd NoBeC talk, or the Norms and Behavioral Change talk. My name is Samira Sayed, and I've recently joined as the new Managing Director of the Center for Social Norms and Behavioral Dynamics at the University of Pennsylvania. We have an exciting agenda for you today, and our agenda includes two excellent talks by an early career researcher, Lukas Reinhardt from the University of Cologne, and our keynote speaker, Dr. Erik Kimbrough from Chapman University. Following these two talks, we'll have a Q&A segment open to all participants towards the end of today's session. For those of you who may be joining us for the first time, the NoBeC talks are organized by the Center for Social Norms and Behavioral Dynamics at the University of Pennsylvania, with the support of the Philosophy, Politics, and Economics, or PPE program, and in partnership with the Master of Behavioral and Decision Sciences program at UPenn. For further context, the Center for Social Norms and Behavioral Dynamics is a research center at UPenn, which provides specialized consulting, research, and training services to organizations throughout the world seeking to enact positive behavioral change. Please note that we do have a full schedule of NoBeC talks ahead of us through the end of this year, with speakers from the following institutions, as you can see here. So the Università Cattolica del Sacro Cuore, the University of Chicago, the National Research Council of Italy, Carnegie Mellon University, and the Norwegian School of Economics. So you can visit our website for more information and to add these future talks to your calendar. And lastly, before we turn to our first speaker, please note a few of the ground rules we have. You should be automatically muted, but if not, we kindly ask you to mute yourself while the speakers are presenting. If possible, please do keep your camera on so that we can have a more interactive and lively conversation. And for any questions, please use the chat at any time or raise your hand towards the end of today's session when we will have the Q&A. Last but not least, the recordings of these NoBeC talks will be uploaded to our website, and the link is as follows. So with that, we'll go ahead and turn to our first presentation, which is by an early career researcher, Lukas Reinhardt. Lukas is currently a PhD candidate in economics at the University of Cologne. He is also affiliated with the Identity and Conflict Lab at Penn and the Center for the Study of Social Cohesion at the University of Oxford. In his research, Lukas focuses on social identity, social cohesion, and intergroup conflict. Lukas's presentation today is on the price of identity, material interest, perceived group threat, and in-group solidarity. So since Lukas is on the call with us, we'll turn to him if he has any few words to add before we move over to his recorded presentation. Lukas, over to you.
Yeah, thank you so much. Hi, everybody. It's really great to see so many of you, and I'm really grateful for presenting here. I'm very curious for your comments and really look forward to hear your thoughts and comments and your feedback on that. I'm going to write my email address in the chat, so you can either give me feedback in the chat or write me a short email. And yeah, I really appreciate if you have any comments on my talk. Thank you so much.
Great, thank you so much, Lukas. And now on to your presentation.
Hi, everybody. Thanks for having me. Today, I'm going to present work joined with Eugen Diemann and Nicolas Amanis called The Price of Identity, Material Interest, Perceived Group Threat, and In-Group Solidarity. Let me motivate our topic. We all know that tensions and inequality between racial groups are still a persistent phenomena in the US and other countries. Now, in our study, we study how Black and white subjects react to fair and unfair treatment of their in-group by others in an online experiment. And in this experiment, we analyze whether subjects react differently to inequality caused by outgroup members, which we call identity threat, than to inequality caused by chance. Moreover, we study effective motives rather than instrumental ones. Let me talk a bit more about our design. So as I said, we run an online experiment. We have a US sample and a sample size of more than 1,000 participants. And here's the chronological order of our experiment. So first, we elicit demographics, run a short attention check, and inform participants about the instructions. Then we run some decoy allocation decisions. where subjects can split some money between random groups, and we do that in order to veil that we want to measure racial bias here. Then we have the treatment phase, and in the treatment phase, subjects are informed that either another person or the die will determine the split of 100 tokens between a black group and a white group. Therefore, we have three between subject conditions. We have a die condition where the die determines the split. We have a white decider condition where a white person decides the split. And we have a black decider condition where a black person decides the split. Afterwards, we elicit our outcomes. Subjects have to indicate their preferred split of another 100 tokens between the same groups for the three scenarios, which are an equal split. The black group gets more, or the white group gets more in the previous allocation. Finally, we elicit willingness to pay. We ask subjects whether they want to pay small amount of tokens to implement their preferred split they indicated before in each scenario. All right, let's talk a bit more about the outcome measure. Subjects, as I said before, have to allocate another 100 tokens between both groups for the following three scenarios. The first one is that the black group got more previously, that the black group got 80 tokens and the white group 20. The second scenario is an equal split, and the third scenario is a split where the white group got more, where the white group got 80 tokens and the black group got 20 tokens. We use in our experiment real pictures of real people, who are Penn students and click workers, who got real money. All right, let's look at subjects' allocations to their in-group in each scenario. So these bars, as I said, capture subject allocation to the in-group of the subject in each scenario. And I want you to take away three things from this graph. The first result is that in case previously we got an equal split, most subjects react relatively fair, but we have a small significant in-group bias in this case. The second result is that in case the in-group of the subject got less, subjects partially compensate their in-group and they give their in-group 66 tokens. A full compensation would mean that subjects would allocate 80 tokens to their in-group in order to make sure that in the end, both groups have the same. And so here they partially compensate their in-group. That result is that in case the in-group got more previously and the out-group got less, subjects partially compensate the out-group. They give 39 tokens to their in-group, and so they give more to the out-group than to the in-group. And we see that, as before, we don't observe a full compensation, in which case participants would give 20 tokens to the in-group to make sure that both groups have the same in the end. And it's the case that subjects compensate the out-group to a lesser extent than their in-group. All right. Our next result is that black subjects react to identity threat, whereas white subjects do not. So first, a reminder, the identity threat is the following. It is inequality to the disadvantage of subjects in group caused by an outgroup member, compared to a situation where inequality to the disadvantage of subjects in group is caused by chance. So our fourth result is that in case of identity threat, black subjects allocate 9% more tokens to the in-group than in case of inequality by chance, which is significant. And we don't observe a significant equivalent effect for whites. There, the effect even goes in different direction. Our last result is that black subjects also have a higher willingness to pay than white subjects to implement the allocation decision in case the in-group got less previously. All right, thanks for listening, and we highly appreciate your feedback.
Excellent. Well, thank you so much, Lucas, for that excellent presentation. And we've noted that if anyone has questions for Lucas, please, you can feel free to put them in the chat, and Lucas will be here. He's also very kindly shared his email address. So you can feel free to engage with him in the chat as we proceed. And so with that, we're going to turn to today's main talk, which will be by Dr. Erik Kimbrough. Erik is a professor of economics in Chapman University's Argus School of Business and Economics, and a member of the Smith Institute for Political Economy and Philosophy. I'll just stop sharing my screen now so that Erik, you can go ahead and present as I continue to introduce you. So Erik's research uses experiments to study the economics of rule following, social norms, conflict resolution, cooperation, and institutions, among other topics. His talk today is on measuring norm uncertainty and multiplicity. And with that, we'll turn it over to you, Erik, and thank you again so much for joining us. Yes, you're just muted. There we go.
Okay, managed to unmute myself. Thank you. Thank you, everybody, for coming. I really appreciate it. Thanks, Lucas, for the nice talk before this. That was interesting. I'll send you some thoughts afterwards. Okay, so this is sort of two papers in one. You get two for the price of one today. This is measuring norm uncertainty and multiplicity. So I'm going to kind of set this up by showing you a set of experiments that we ran sort of with a convenience sample that was really large, that gave us a chance to test some basic assumptions about the norm following framework that many people use these days, and some of the unexpected things that we found when looking at that data, and then sort of use that as a license to set up the design for the next study. So sort of that's the layout of the talk, is unexpected results about multiple norms, and then how can we find them directly rather than accidentally. Okay, so I think in this crew, it's not objectionable to say that norms influence choices. This is a commonplace, norms matter. And one implication of that is that choice data alone is insufficient to reveal norms. And the reason is that there are multiple potential mappings between normative motive and outcome, right? So in a dictator game, you could give an equal split because there's a norm of splitting things equally, or you could set an equal split because there's a norm of being generous to other people. Behaviorally, you can't just directly pull those things apart from a single choice. And so a consequence of this is that many of us have worked to try to develop techniques to actually measure norms more directly and thereby understand their influence on choices. So this talk is sort of within the realm of people who are trying to measure those things. What do I mean by a norm? Loosely, I would say norms are beliefs about and standards of appropriate behavior. They may serve to coordinate actions and expectations in interactions with multiple equilibria. In general, for a norm to be effective, it's assumed that we need one, a shared understanding of the standard, so some kind of common expectations, and two, a motivation to follow the norm, that people have to care about the norm to some extent. That might be for instrumental reasons, because not following it results in punishment or some bad outcome, but there's also a notion that some people care intrinsically about doing what they ought to do from the point of view of certain groups. And so, you know, as long as that motivation is there, you can have a norm be effective. So if you accept all that, then two components of a norm have motivated experimental techniques where we try to measure those things more or less directly. And so two prominent measures are due to Bicchieri and Shao and Kripke and Weber. And then in the idea that people intrinsically care about norms, myself and Alexander Vostroknatov have tried to measure this propensity, this idea that people are heterogeneous and how much they care about norms. And so the first paper that I'm going to quickly go through today is sort of testing some of the basic assumptions, the framework in which we measure both normative beliefs and norm following propensity. And so this is part of a large public health experiment where we sort of tacked on some behavioral games because we were going to get 1,500 respondents in a panel setting that would allow us to test some of the basic assumptions of norm following models. So this is with a diverse team of people from you know, public health, medical departments, and so on. It's actually a project about interventions to reduce smoking, but I'm not going to talk about any of that today. I'm going to talk about the parts that are more related to the norm following framework. Okay, so a couple of assumptions that I think undergird the way people talk about and use norms, maybe implicitly, maybe explicitly in various cases. One is that norms are often seen as unique. So we're going to call this sort of the uniqueness assumption, that in a given setting, there is a norm. A norm is conceived in terms of a single prescriptive action. So if you're using the Krupke and Weber method to elicit beliefs about the norm, this might be the norm that has the highest average appropriateness, right? It's the most appropriate action. Some of the early papers explicitly ask people, what's the most appropriate thing here? When people talk about tipping norms, they often say, the norm is to tip 20%. I myself am guilty of this. In our 2016 paper, we say there is a clear norm of equal division, right? So there's sort of this built into the idea that norms are going to be explaining behavior, is this assumption that there's a unique norm that maps to a particular setting. I'm going to argue that actually we should be thinking about norms not as specifying a unique action, but rather as a profile, because what matters in a model of norm-dependent preferences in which people trade off some notion of their consumption utility against this view about what they ought to do from the point of view of the norm, what matters is the shape of the function that matches actions to normative evaluations. If something is only a little bit less appropriate than something else, that makes the appeal of being selfish and choosing that inappropriate thing stronger than if it's a lot more appropriate. So you need to think about the whole shape of the function. So that's one reason to think that it's not just a single prescriptive action, but I think this emphasis on there being a shared and unique norm shouldn't necessarily cause us to dismiss individual variation in responses as mere measurement error. So one implication of this is if individuals have deviations from the average, if you see that individuals deviate from the average, but they do so in a structured way, then we shouldn't think of those as just measurement error, but we might think about them as evidence of multiple contemporaneous norms or of ongoing normative change. So another sort of assumption that we have is that the norms are stable over time, right? And one way that I think you see this is that very rarely do people measure the norm more than once in a particular setting, right? All the studies, it's a one-off measurement. We elicit the norm, we compare it to behavior. We're not measuring the change over time. So I think there's reason to doubt both the uniqueness and the stability assumption. For example, I gave the story about you could have a generosity norm or an egalitarian norm in a dictator game. I also think there's reasons to potentially doubt stability. We know that norms change over time in various cases. And so we wanted to try to give a test of these two basic hypotheses about norms that seem to underlie the literature in this sample that we were able to access. So what do we do? Well, we have 1,468 adolescents in two locations in Bogota, Colombia, and Belfast and the surroundings in Northern Ireland. And we conducted the same measurement tasks twice, 10 weeks apart. So we're going to measure individual propensity to follow norms. And we're also going to measure normative beliefs about giving in the dictator game. And the reason we're using the dictator game is because that's very commonly studied in this literature. I think it also is something where, you know, intuitively we can see reasons that there might be more than one norm. So that gives some appeal here. Okay, so what do we find in this paper? Well, so how stable are the distributions of normative beliefs and norm following over time? On average, we find they're quite stable. We see pretty similar distributions over time. But at the individual level, those beliefs and propensities are a little bit less stable. In particular, normative beliefs seem to be shifting in our 10-week period, which gave us some pause. You know, there's this idea that we have a stable norm, but if on average people's normative beliefs are different 10 weeks later than they were at the beginning of the study, then there's reason to be concerned that maybe that stability assumption and perhaps as a consequence that uniqueness assumption isn't correct. So then how much heterogeneity in beliefs is there? We actually find quite a lot, and I'm going to show you how we identify that. And how much structure undergirds that heterogeneity? Turns out a striking amount. We can actually explain the distribution across people in terms of a set of 5 norms that appear to capture a lot of the variation. So 5 different ways that people look at the same game. And then we also can show that people who hold beliefs that differ from their peers at time 1 are the ones who are likely to report changes in their normative beliefs at time 2. So being different from your reference group seems to be associated with changes in your beliefs. Sorry, I keep losing my ability to click through whenever a new person gets added. Okay, so the mechanism study. As I said, this was a study designed to assess the mechanisms through which 2 anti-smoking interventions operate. As a result, we were collecting panel data before and after the implementation of these 2 anti-smoking interventions. And we use this as an opportunity to collect data on norm following propensity and on norms in the dictator game, among many other things. So we included entire school year groups from 15 middle schools. There were about 100 students per school. We got about 90% of the students in each school year group to participate, and that's including attrition. So it was pretty well implemented, and we got the same people twice. We tended to oversample schools in lower income areas because there is where the risk of uptake for smoking is higher. And all this was collected on iPads using Qualtrics. We paid people for either week 1 or week 10 using randomization to decide which week they would be paid for each task. What did we do? Well, we collected a measure of their norm following propensity that tests the willingness to follow rules, even when it is costly to do so. So some of you may have seen a version of this before. We tell people the rule is to put the balls in the blue bucket, but for each ball you put in the blue bucket, you only get 5 pence in Northern Ireland, and for each ball you put in the yellow bucket, you get 10 pence. There's no punishment for violating the rule. There's no, sort of anybody standing behind you, making sure that you do it. And what we think this gives you is a measure of people's propensity to follow norms, because why else would you put money in the blue bucket other than the belief that you ought to, that because they told me this is a rule, I ought to follow it. And so we measure heterogeneity in the propensity to follow norms using this task. And we have a couple of papers previously where we show this relates to norm consistent behavior in a variety of games. So we measure that at time 1 and also at time 10. And then we also measure norms for the dictator game. So this is just a sketch. This isn't what it actually looked like. We would give them all 10 possible actions, giving between 0% and 100% in increments of 10% of some pi. We ask people, how appropriate is it to do each of these actions? And they are incentivized to match the most common response given by other people in their school year group. So the idea is your reference group is other peers in your school, in your same age group, and you get paid if you can guess the most commonly reported belief by others. If there is a single norm, it should serve as a focal point to resolve the coordination problem that's introduced in that game. You can make money by everybody reporting the norm. Okay, so we're going to do the standard Krupke and Weber, both at time 1 and at time 10. And then we also collected measures of subject social networks. So one is just we know what school year group they're in. Another is we know what class they're in. And then we also collected nominations of who are their friends in a pre-experiment survey. So they could nominate up to 10 individuals in their school year group as their friends. And so we have this social network data actually collected at both time steps, I believe. Okay, just briefly, baseline characteristics. So as I said, we got about 90% participation across all of them. We had in Northern Ireland 825 total students, in Bogota 999. So that gave us a larger number than I reported before. Some of that is due to attrition, some of that's due to incomplete responses. Not everybody answered every question. And so we end up with about 1,500 where we have all the data at both time 1 and time 2 for all of our analyses. As you'll see, most of the respondents were age 12 and 13. In Bogota, they skew just a little bit older. And there's a few students that are a little bit younger, but for the most part, the respondents are all similar age. There were 2 interventions, but I'm not going to talk about that. The main thing that you need to know about those interventions is that we have no reason to expect that they would influence beliefs about what's appropriate in a dictator game. They were interventions about smoking. They were showing you pictures of a diseased lung and saying, don't smoke, or they were getting your peers to come around and tell you, hey guys, smoking's not cool. Those were sort of the 2. So we don't have reason to think that those would cause differences in the dictator game norm or in norm following propensity. Okay, the first thing we want to check is, are the norms stable and are norm following propensity stable on average over time? So here I've shown you the histogram of the rule following task at wave 1 and wave 2. On average, we see no difference in the norm following propensity over time. The difference between these histograms is not statistically significant. Here you have on the vertical axis the appropriateness of different amounts that you could give between 0 and 10 pounds in the case of Northern Ireland, and I think it was 0 and $10,000 in Bogota. Or Colombian pesos, sorry. And so what we see here is that the distribution looks pretty similar, but if anything, there's just slightly steeper norm on average in the dictator game at time 2. And so on the whole, it looks like beliefs are stable, but this is looking at the distribution as a whole. We should also look at individual level variation. So what we do is we take the difference between what the individual did at time 1 and what they did at time 0, and then test whether that difference on average is different from 0. In the rule following task, we find no significant difference. There's no change in people's rule following propensity on average. But in the dictator game, what we find is that for these intermediate amounts, giving 1, 2, 3, and 4, giving 7, the appropriateness of these goes down between time 1 and time 2. So there is evidence that norms are steepening over time. So though there's no change in this propensity, we do see some change in norms. And we thought, well, what's driving that? We should go trying to figure out, why are we seeing a change on average in just a 10-week period when we haven't done any intervention that we expect to create this change. Just to show you the data at the individual level, these are histograms. Christina, I see your hands up.
Just a very simple question. Do you ask about appropriateness before they make a choice or after they have made a choice?
They actually never make the choice. We just elicited the norms.
So you say what is most appropriate, blah, blah, blah. You use the Likert scale, etc.
Exactly.
Okay.
Yes. Yes. The standard Krupke and Weber. So what we were doing actually was adapting that technique to measure norms about smoking. And so we included the dictator game as a sort of negative control because we wanted to make sure they understood the task and we knew what to expect from a dictator game. And then we said, you know what, we'll include it twice because it lets us test these assumptions about stability of norms. So yes, it was the familiar task.
Yeah.
Okay, so up here is just the individual level changes in norm following or rule following propensity from our bucket task. These other ones are the distribution of changes in the response to all the other individual actions. And what you see is some of these are skewed left, and those are the ones that show significant difference over time. These are people are saying giving 1, giving 2, giving 3, and 4 are less appropriate at time 2 than they were, or at time 1 than they were at time 0. Okay. So how do we interpret this, right? If there are not big aggregate changes, but there are actually some people who are changing their reported normative beliefs quite a lot, what's going on? How do we interpret this? So we went and talked to the team and there were public health researchers there who are used to using this survey data and trying to identify types, underlying types from the distribution of responses. And so we found this method known as random intercepts latent transition analysis, which is like a finite mixture model that uses panel data. And what it does is take the distribution of responses and models them as a composite of a finite number of component distributions, which are latent types that explain the variation in normative responses. And so what we're thinking about is each type as being a different norm that somebody might hold. And then we're trying to get the model to spit back what's the best fitting set of types given the data at time 1 and time 2, and the possibility that people can transition between types over time. It's called a random intercepts latent transition analysis because we also allow that there's some idiosyncratic persistent component between time 0 and time 1 that's unrelated to the type, but that also explains their responses. So we're conditioning that out, some time invariant individual level stuff, and then looking at this distribution of types. The way this works is a little different from the typical finite mixture models that you may have seen in economics, in that the types aren't specified ex ante. It's actually the model goes and tries to find the best fitting set of types given the data. So what you do is specify a guess about how many types there are, and then the algorithm computes for 3 days in some cases and spits back out the best fitting set of types. And then you can compare models with different types using model fit statistics to decide what the correct number of types for your sample is. And so, the model fit statistics are like AIC and BIC. What we find with our data is 5. I'm going to show you what those 5 look like. I think we could quibble about whether 5 is the exact right number. But I don't want to get distracted by that at this point in the talk. Maybe we can save that for the end. The point is it's a lot more than 1, right? No, the model in which there's 1 type is clearly wrong. And 5 is the one that fits the best for our data. It also estimates a transition matrix that gives you the probability of switching between types over time. So if you're a type 1 at time 1, it gives you the probability of becoming a type 5 at time 2. And as I said, it controls for unobserved time invariant individual level stuff. So what does it do? It gives us these 5 different classes of norms. So what I'm plotting here is the expected response given the type for each of the 5 types. And then here again is just the average. So what you see are 5 different ways that people might view the dictator game. We think of these as 5 different potential normative perspectives on the same game that come right out of our data. So we call this one the egalitarian consequentialist norm because it's egalitarian, but it gradually gets more and more inappropriate to go away from the egalitarian outcome. Whereas this is more like a deontological norm where there's a single normatively best outcome and everything else is equally worse on either side of it, right? They're all bad and they're all equally bad. This one is somewhere in between. It's weakly egalitarian consequentialist. We think of this one as egoistic nearly because all but 2 allocations are seen as fine. Almost everything is seen as appropriate or at least not inappropriate. And we consider this a generosity norm. It's increasing until the equal split and then remains high thereafter. So the implication of this is that those stable averages that I showed you are concealing this striking heterogeneity in normative beliefs at the individual level. That said, these beliefs seem to have structure and they seem to be interpretable. We can make sense of these in terms of common moral categories that I think we all sort of either intuitively know or have read about at some point. And again, you know, the labeling maybe isn't 100% perfect, but I think we're characterizing them in a way that at least makes it intuitive.
Erik, quick question, just super
Yeah.
quick. How much of this do you believe is sort of a function of you extending the standard caliber measure by like 2 additional options, and maybe now you have a little bit more noise in the coordination? So do you think you would have 5 types with a standard approach too, or how much is that related?
That's a good question, and it's an empirical question. I don't know. So if there's a lot of noise, those I would think in this model, there's a pretty big penalty for adding additional classes, right? There's a lot of parameters that get added to the model when you add another class because you've got to get those transition probabilities and the probability of giving each possible response for each possible action. So I would think that it would still have an incentive to sort of find the middle ground between those and just assign a lot of weight to both of them. So these averages would look pretty similar. If people are like unsure, between somewhat appropriate and very appropriate, if they're unsure between very appropriate and extremely appropriate, I would expect both of those to just get some weight in the type. So I don't think it should be super sensitive to that, but it's an empirical question whether it actually is. These are the transition probabilities or class counts. So some of these are quite stable. If you're a class 1 at time 1, there's a 60% chance that you'll still be there in the second wave. These intermediate classes, so again, just to go back, the deontologists aren't as stable. These weaker consequentialist ones aren't stable. If you'll notice, the average got steeper. So you might think that some of these ones are steepening, right? The 2 that are egoistic or more weakly egalitarian are possibly steepening over time. In any case, I would say a striking share of subjects actually do change their class. Almost half of them are changing between time 1 and time 2. So there's not a lot of stability in normative beliefs about this game. For those of us that think the dictator game is a very messy measure of something, this is maybe not surprising, but it's one of those things that people interpret the dictator game very narrowly, and I think these data suggest that that's a mistake, that there's a lot going on in the dictator game that calling it just a measure of altruism or prosociality seems to miss. Finally, I don't want to spend a lot of time on this, but as I said before, if you are in the same latent class as other people in your friend group or classroom or school year group, you're less likely to change classes over time. So we do get some sense that being the same as your peers makes you less likely to change. If you are different from your peer groups, you're more likely to change. So this is the percent that change class given that nobody in their group is the same as them. There's a 70% chance that if you were different from your school group, you would change. Obviously this counterfactual doesn't really exist, but that's the estimate. And then if you were the same as everybody, that would basically drop down to 0, right? You wouldn't change over time. Okay, so we started out asking how stable are norms and norm following propensity over time in this data. And then we asked, okay, given that we aren't on average that stable in terms of norms, how should we think about this heterogeneity in responses? So we went looking for this method. We found random intercepts latent transition analysis, It revealed 5 different types of normative beliefs in our sample. We think those types are pretty readily interpretable in terms of existing normative theories or frameworks. And we find that there's, plausible, sensible peer effects in who changes their beliefs. That all said, I think in some sense, we only get multiple norms here if there's genuine disagreement and if people don't understand that other people disagree with them, right? Because of the incentive to coordinate in the Krupke and Weber task, the fact that we find 5 different norms here is a little bit surprising. It suggests that subjects either really don't know what other people believe or there's some kind of error. And so I think this opens the door for us to go and ask, is there a way to actually measure this multiplicity more directly? And so that's going to lead into the second paper where I think this is, Sasha is going to be able to jump in and answer questions more readily in the chat if you guys have them. So there's a couple of things that we don't know. One is we don't know whether subjects are aware of the multiplicity. Do they know that there are multiple perspectives on the same game? Or are they themselves uncertain about what the norm is? They're not sure which of the norms that could apply actually does apply in the setting. And so we're going to try to get some theoretical handle on what norm uncertainty, the relationship between it and multiplicity. And then we're going to propose, and I'm going to show you some pilot results of a new method that tries to get at measuring this multiplicity more directly. So I hope at this point I've convinced you that even in the simple dictator game, there are multiple normative perspectives that people bring to bear on that same game. And now that we can go try to measure something like that more directly. So this is work with Eugen and Folko Panizza and Alexander Vostrok-Nutov. And thanks to IFRI for funding our experiments, which are ongoing. Okay, so what is normative uncertainty? What is it that people are uncertain about? So one thing you might be uncertain about is how tight or loose a norm is. How likely am I to be punished, say, for violating this norm? How bad, how much worse is it to violate this norm a little bit than to violate it a lot? And that kind of uncertainty doesn't necessarily imply that there are multiple norms. It might be that I just don't really understand how binding or how sharp a particular norm is. On the other hand, there could be genuine uncertainty about what is normatively best, right? There might be different rankings of these outcomes. Stefania, I certainly think that looking among young people is a place where norms are most likely to be unstable. So yes, I would say we're biasing upward. People get more set in their ways as they get older. I would say that seems intuitive.
Yeah, no, I agree. Thank you.
Yeah. Yeah, so uncertainty about what is normatively best would actually imply multiple candidate norms. So what we're going to do is try to offer a theoretical framework that can clarify these 2 different notions of uncertainty, and then propose an elicitation technique that would directly get at the second case when there are multiple norms. So let me go back to the definition of the norm that I gave very loosely at the beginning and try to make it a little more precise for you now. So take a set of C of outcomes. You can think of these as terminal nodes in a game or allocations in some choice set. And then there's n players. So at each outcome, players have payoffs that result from that outcome, and they get some utility as a consequence of those payoffs. And we're going to define a norm as a function that assigns to all elements of that set of outcomes an appropriateness. Right? So we're going to borrow the way that Krupke and Weber do this and say that appropriateness is bounded between -1, which is the worst, normatively the worst outcome, and +1, which is normatively the best. And a norm is a function then that assigns those appropriateness scores to outcomes. And then we're just going to say in these models, this is the standard, that agents maximize their norm-dependent utility. So they care about their consumption utility, but they also care about how appropriate their action is, and they do so heterogeneously with phi varying between 0 and infinity. If phi is 0, you've got a standard utility maximizer. If phi is infinite, people only care about norms, right? Okay, so then we can think about tight and loose as being properties of this function eta. So I'm going to propose a couple of definitions here to you to just kind of fix terms. Let's suppose that in a set of outcomes C, there's a unique element of that set C star, a particular outcome, for which the norm assigns a value of 1, meaning it's the most appropriate allocation, right? There's some allocation that is the most appropriate. It gets a score of 1. Then suppose that for all the other allocations in that choice set, there's a negative one being assigned to it by that function. We're going to call a norm that has that property maximally tight. So there's one most appropriate outcome and everything else is extremely inappropriate. That would be a maximally tight norm. We think that's consistent with the view of tightness and looseness that relates it to punishment, right? Because everything else is going to be seen as a large deviation. There's strong incentive to follow that singular norm, do the normatively best action. Going the other way, take another norm function such that for all the elements of the set, there's some constant normative appropriateness assigned to all the outcomes, right? So everything is considered equally appropriate to everything else. We can call this constant norm or constant appropriateness norm. We would call a norm for which all actions have a constant appropriateness maximally loose, right? So here everything goes in some sense. There's no most appropriate or least appropriate action. Everything is considered equally appropriate. The maximally tight leaves no uncertainty about what one ought to do, whereas a maximally loose norm leaves complete uncertainty about what one ought to do. All things are equally appropriate. More broadly, between those two, we can define a spectrum of norms that are ranging from maximally tight to maximally loose. You can come up with some metric on that space. Perhaps entropy would be a candidate for that, and define a norm function as tight if the distance between the maximally tight norm and the norm you're looking at is less than the distance between the maximally loose norm and the norm you're looking at, right? So the further you are from the tight norm or the loose norm, the more loose or more tight you are respectively for a given norm. So then if we use this definition, we go back and look at the data that I showed you from the previous study, we can say that the average norm became slightly tighter in wave 2, right? We can think about this steepening of the norm function as being an increase in tightness of the norm. Or if we go and look at 5 different norms, we can compare them in terms of tightness and looseness. So the egalitarian consequentialist, well, it's an egalitarian norm, but it's tighter than 3, which is this weaker egalitarian consequentialist looking norm, right? This is tighter because it's steeper. We can say an egalitarian deontological norm, that's very tight. That almost matches our definition of extremely tight, except this doesn't go all the way up here and these don't quite come all the way down here, but it's a very tight norm. On the other hand, we can say the egoistic norm is quite loose, right? Because almost anything goes with that. The distribution is compressed. So notice, even in what we're looking at here, some disagreements about the norm are about the tightness and looseness. So compare class 1 to class 3, that could be uncertainty about how tight the norm is. But others actually do imply multiplicity. This is a different norm. This is a different norm from these, right? So how should we think about it if there are multiple norms? Let's assume now that there are multiple norm functions. We'll subscript them with K. We can say that K indexes say relevant reference groups. That's one way to think about there being multiple norms, right? In politics, there might be norms for Republicans and norms for Democrats. We can assume that there are some probabilities, P sub K, that sum to 1. And those probabilities are the probability of each norm, or a person holding each norm, right? It's sort of the size of the groups, the relative size of the groups. Then we can define an expected norm function, mu of C, as the weighted average, population weighted average of these multiple norm functions. And if you have a Bayesian rational agent, then you can just continue to model them in the way we did before. The mu would just substitute for eta in that norm dependent utility specification that I showed you before. So what can we say about these mu functions as compared to eta functions? We can say that I shouldn't say no, it's actually only the degenerate mu could be maximally tight. If there's only one norm, then mu and eta are going to coincide perfectly. And if that one norm is maximally tight, then that one norm, the mu and the eta would both be maximally tight. But as long as there's more than one norm and they're not identical, then the average of 2 norms is going to be less tight than the individual norms that underlie it. So multiplicity, an implication is that empirically we might mistake looseness for multiplicity and vice versa, right? It's hard to tell whether a norm is loose or whether there are multiple norms existing in the same setting. See what I mean? Consider 2 norm functions, an eta, which is a certain norm function, and a mu, that's an expected norm function over multiple norms, such that the appropriateness they assign to an action C is the same for all elements of the choice set, right? You could imagine that being possible. Well, in that case, we're not going to be able to tell whether the norm is loose, but certain, or whether there are multiple norms that each of which might be tight, but aggregate into a relatively looser appearing average norm. Yeah, I mean, so we would have to come up with, and Britt, I see your question. We would have to come up with, and I think decide on what our distance metric is in that space to get an answer to that. To the right of the equal split, we could say that norm is pretty loose, but to the left of it, it's pretty tight. That might be a reason why, even if people believe the generosity norm holds, then maybe they don't tend to choose allocations more than the equal split in a dictator game, because it's not that much worse to just choose the equal split. That's a good question. Okay, more importantly is that in general, the Kripke-Weber method is not going to be able to pull these apart. If everyone has complete information and coordinates on the certain or expected norm, responses are going to be indistinguishable in the Kripke-Weber method. So as I said before, the only way we can get this evidence of multiple norms is if people genuinely don't know what other people believe, or if they are wrong about what they think. So how can we do it directly? How can we actually incentivize subjects to reveal that they believe in multiple norms? One response might just be, well, we've incorrectly specified the reference group, right? So there's only multiple norms because you don't have the reference group pinned down correctly. And I think that's plausible. I don't think there's anything necessarily wrong with that argument. But if we know what all the reference groups are and the norms associated with them ex ante, then why do we need to measure norms in the first place? So I think that's an answer, but it's not a satisfying answer for researchers who are trying to understand norms in a place where we don't fully have a picture of what they are ahead of time. So instead, what we want to do is actually find a way to measure multiplicity directly by generalizing the Kripke-Weber method such that subjects actually have to draw multiple paths through those allocations, and then assign probability weights to each of them, and do this in an incentive compatible way. So the way we're going to incentivize this, again, loosely speaking, is that subjects should only draw norms that other subjects also draw. If you draw a norm that other subjects didn't draw, then you're going to lose out on the probability of winning a prize. And you should assign weights to them that match the average weight assigned to those norms by others. If you assign more weight to some picture that you draw than other people on average assign to that, then you're going to lose out on the probability of winning the prize in proportion to the distance between your weight and the average weight assigned to that norm. We're borrowing a method known as BESA, belief elicitation by superimposition approach by Fragiadakis et al. Okay, so how do we do this? We walk people through an example about tipping at a restaurant. We say some people might say that 15% is an appropriate amount to tip, and might consider other options as less appropriate. For example, they might consider 18% as neither appropriate nor inappropriate, and 20% as inappropriate. Please click on the chart below to rate 15% as appropriate, 18% as neither, and 20% as inappropriate. So we walk them through. They fill out this example, and then we say, but other people might have different views. So then we ask them to draw two other examples, and notice as you fill in your examples, the ones that you submitted before appear in little miniature versions at the bottom of the screen. So we're tracking both their current belief and the other ones that they've drawn. Once they've drawn multiple views, we've trained them on this mechanism. We take them through and explain to them the incentives. So we tell them, you're going to be seeing different scenarios. We want you to draw all the different views that you think people have about what's appropriate in this scenario, and then guess how many people out of 100 hold each of those views that you drew. Has to sum up to 100. We're going to recruit 200 people. If you draw the exact same set of views as other people draw, and you assign the exact same proportion of the population to them as other people do on average, then you're going to get your prize for sure. But deviations for that are going to cause you to have a lower probability of winning the prize. I think I'm going to skip this because it's a little bit in the weeds, but if the incentives are unclear, I can come back to this during the Q&A. So then what we do is describe a simple dictator game. Someone's allocating $4 between themselves and a stranger. And we say you can make between 1 and 10 drawings to represent different views that you think exist for this game about what's appropriate. and we ask people to draw these. So somebody could draw a norm that looks like an egalitarian norm that's shaped like this. They could submit it. Maybe they could draw a tight norm that says everything's inappropriate except for the equal split, which is appropriate. Or they could draw a loose norm, which says that anything goes. All these are equally neither appropriate nor inappropriate. They keep drawing and adding norms until they think they've characterized the full set. Because there's 5 actions, there are 3 to the 5th possible paths you could draw through this, 243 possible paths. We only allow them to draw up to 10. And then they have to assign probabilities to each of these. So we give them a slider. The sliders have to sum up to 100. And they're saying 60 out of 100 people will say this is the norm, 20 out of 100 will say this is the norm, and 20 out of 100 will say this is the norm. We also did this for a real world norm. So we were asking about appropriate tax rates for high earners. We told people about the current highest tax rate is on individuals earning more than $539,900 in the US. We say Congress is deciding how many cents per dollar these high earners should have to pay in federal income taxes, and we give them 5 options. And we repeat that same task, allowing them to draw paths through the different taxation rates. What do we find? Well, we conducted a pilot so far, so we haven't actually run this with the proper incentives yet. They were just told to behave as if the incentives were in place, and then we asked them some questions at the end about whether they understood it, what they liked and didn't like, and so on. So I should say at this point, we are very much seeking your feedback on this task. We haven't collected the real data yet, and so now is the time when you are most useful to us, telling us how to fix it or make it easier or better. So what I'm showing here are the distribution of the number of norms drawn by people in the dictator game and the tax rate case. There are some people who use their full budget of 10 norms to draw, but the mean and the median in both cases are 5 or close enough to 5. We see 65 unique distinct paths drawn through the actions in the dictator game and 69 unique paths drawn through the tax rates in the tax rate game. What we do then is take the 5 norms that in the population got the most people assigned to them. What are the 5 highest population weighted normative beliefs that people report in the dictator game? So norm 1, you could say, is a generosity norm. Norm 2 is anything goes. They're all neither appropriate nor inappropriate. The third one is they're all equally appropriate. We have the deontological norm, and we have the sort of consequentialist egalitarian norm. So one thing that I find, I will say, deeply reassuring about this is that the 5 most common norms look a lot like the 5 norms that we found before. The only thing we're missing, and it might be because, as Eugen pointed out earlier, we make the scale simpler here, are the sort of disagreements about how steep this is around the egalitarian norm. So the average norm elicited from this, so again, this is the population assigned to the population weighted average, right? So this is based on the probability that people hold each norm assigned to it. We average in a weighted fashion over that to draw this norm. And that's what we get for the average norm in the dictator game. So this suggests to me they're not totally misunderstanding what's going on. We sort of reproduce what looks like the average norm in our dictator game from before. And the 5 most commonly listed norms have a lot of overlap with the ones that we got in our sort of data-driven fashion previously. For the taxation rate, interestingly, it peaks on average. The appropriateness peaks at the current marginal tax rate on high earners in the federal tax for the US. And we get norms that people, all of them are equally appropriate. 3 of the ones that are most common suggest that higher rates are more appropriate. And then there's one that's sort of peaked right at the median. On average, though, we end up with a norm that looks like this. So this average is not just including these 5, I should say. This is including all the 60-something norms that people responded. And the same was true for the dictator game when I computed the average here. So I'm showing you the 5 most popular and then the average, which includes all 60 responses. So I would say at this point, we are happy with the responses not looking totally out to lunch. We recognize the task is a little bit complicated. And so, that was a worry for us. That's one of the reasons that we simplified here to include only 3 allocations on the left, or 3 ratings on the left-hand side rather than 4 or 6, because it just reduces the number of possible paths through the figure. But on the whole, we think we're getting sensible results with this. And given that people are on average drawing multiple norms, they do seem to recognize that, reasonable people disagree on what is appropriate in these various settings. There's not just a single norm about taxes. There's not just a single norm about how to play the dictator game, and they know it. So what do I think about all this? I think this highlights the value of doing experiments. I mean, we sort of just naively decided to test the basic assumptions of the norm following model with that panel data. I said, what can we do with the fact that we're collecting this twice? And so we added the dictator game norm elicitation on there twice, and we added the rule following task on there twice, to sort of say, everybody's assuming these things are true. How true are they? And so when we did that, we found that norms weren't entirely stable. So I think, even things that you think are worth testing. I think that's something I want to emphasize with this talk, because you might learn things, you might find a whole new set of questions to ask about how to interpret the evidence that you find, and then how to get that same kind of evidence more directly. I'd also say this project has really highlighted for me the value of doing interdisciplinary work. So for one thing, we would have never heard about latent transition analysis probably unless we were working with these public health researchers and psychologists who use it all the time. And then, digging into it, we were sort of troubled by this independence assumption that was being made that the type is all you need to know about somebody to explain their data. And we discovered this random intercepts latent transition analysis, which had just been introduced. The paper on it was published in 2022. And so then we were able to estimate this structure that's underlying the heterogeneity and look at changes over time. And I would say it's changed how I think about norms, even in these simple games. I showed an example from my own writing before where I said, the norm is, there is a clear norm. And I think between these 2 studies, I'm now a lot more cautious in thinking that we should pin down behavior in terms of a single norm. We need to think about what are all the perspectives that people might bring to a particular choice problem, and how do we measure those things, and how do we understand their influence? Finally, we had started working on normative uncertainty of the kind that doesn't require multiplicity, kind of in parallel to this. But then in seeing those other results, it became clear that you could mistake that kind of uncertainty for multiplicity. And so that's sort of, those 2 projects dovetail to create this second project in which we're now trying to measure the norm uncertainty directly. So I think seeing those kinds of results and bringing them to this group helped us kind of build out the conceptual framework. It gave us the things that we needed to be able to explain, and then suggested to us the ways that we could go and try to measure our variables of interest more directly. I think I got it done just in the nick of time. Eugen, you were worried, but I pulled it off. Thank you, everybody, for listening. As I said, we would love to get your feedback. I'm happy to stick around for the Q&A, and then if people want to meet with me outside of the Q&A, you can send me an email. I'm happy to do so. Thank you very much.
Brilliant. Thank you so much, Erik, for that excellent comprehensive presentation. We've now allocated 15 minutes for Q&A, and so please feel free to raise your hand, put additional questions in the chat, and maybe perhaps I can first turn to Christina for any questions and comments you have, and then we'll move onwards.
Thank you. Very interesting. So the big question is, do we have shared rules of behavior? Well, yes. How many? And the type and lose is a little confusing, because the lose, I wouldn't call it a norm or a rule, is anything goes, basically. Okay, so people say, well, it's right to do this, it's right to do that, or whatever. So the tight lose is a little bit confusing. The use of the dictator game is also a little confusing, because the dictator game typically doesn't focus us immediately on a particular rule. And depending how you frame it, people will go in different directions. So I'm not surprised by your result. What I see, I think is very interesting to measure real multiplicity. And real multiplicity is not uncertainty, okay? It's something very different. And if we look, for example, at stronger rules like reciprocity, think of trust games, or fairness, think of ultimatum games, then you may think of multiplicity, because indeed there is a multiplicity. Some people may say 5-5, but 6-4 may look really okay, appropriate, and so on and so forth. So I would like you to look at multiplicity in games where, you know, it's not like everything goes, or in situations, okay, well, like everything goes. But if you want to look at games, I would look at games that are in which the rules are better defined. We have a sense of, there is a range, of course, but, you know, it's a tight range, okay? And so I don't think, you know, the discussion about the reference group, etc. Yes, if certain norms are local, obviously, many norms are local, obviously the reference group matters. And if you think of different reference group, you may have different rules. This is quite trivial. The interesting thing, the interesting question I think you should ask is about certain strong norms, like reciprocity, fairness, etc., in which indeed there is some multiplicity, but is narrow, is not, and you will not basically see the anything goes, the looseness that you see in other occasions. Okay, I would concentrate on that. I think is very, very interesting. Basically, I think the appropriateness as calculated by Krupka-Weber, which is basically a coordination game on normative expectation, okay, is okay for normative expectations, but it may not work that well in this case. And I want to learn more about the method you use. I think it's very interesting. But basically, I want to see what happens with certain rules, or we want to call them social norms, that are sort of quite established, okay, where there is multiplicity still, okay? And you can look at different types, et cetera, et cetera. I think there are different types, but basically there is no looseness in the sense in which, you know, you measure here. That means really nothing matters, everything goes.
Thank you. I think what, if I may react quickly, just to the tight loose thing, I think you're right that, so we were thinking about the limit of looseness is anything goes, right? In the limit, infinitely loose would be anything goes. But yes, you're right. There's no norm once you're in anything goes land. But I would say that the enemy is the limit of looseness. Maybe that's sort of that having no norm is the boundary of looseness, right? So a very loose society will have some norms, but you can kind of do, you know, you can flow between them. It's not a lot. In the limit, there are no norms. That's the maximally loose. So we're not saying that we expect that to exist. It's just to provide boundaries on the definition. In terms of the measuring norms in other games, that's really helpful for us. I appreciate that. Yeah.
Can I add one thing? You completely disregard empirical expectation that to me are very, very important. When you measure looseness, for example, this sort of tight looseness, empirical expectation will matter. Because people, you know, different types may have different empirical expectation about how much people follow the rule. Okay, yeah. And I would measure that. And not just the appropriateness, the normative expectation, which is really a very partial way of thinking of norms. But if you measure empirical expectation, maybe you have a more defined range here, even in looseness. Not in the limit means nothing. Yeah, But when there is looseness, maybe there is a variation in empirical expectation. You say, oh, only 30% do this, or 51%, or 60%, etc. And so you have, different ranges. Sorry.
Yeah, thank you. So I agree, thinking about empirical expectations is going to be important. I guess I would have helped myself by being more explicit that these are the injunctive component of norms that we're measuring, right? We're measuring injunctive, multiplicity in injunctive space. Yeah.
That's very clear.
Thank you.
Great. Okay. Thank you, Christina and Erik, for that. Let's go to the next raised hand. We have a lot of questions. So let's go to Masood next.
Thank you, Erik. I really enjoyed the talk. I have a somewhat abstract comment / question that I'd like to ask you. So I really like the idea of, I interpret your studies basically a challenge to the uniqueness of the norms and then the heterogeneity of the norms, and that's obviously very important. But at the same time, the two examples that you showed in the second study, taxation and also the one prior to that, when you plotted the distribution of, like, on average, they followed a relatively normal distribution, right? So for me, when I think about the theoretical contributions and also the empirical contributions of your studies, it seems to me that, like, in the end, most people abide by and follow certain norms in the normal distribution that you exhibited. So if you were to basically help me interpret this, the two last average plots that you have on taxation and the other one, what would be the best way for me to wrap my head around these two, given that the premise of your work is, again, heterogeneity, to show multiplicity of norms, that you basically challenging the uniqueness of the norms? Because I was expecting to see a different distribution, and both of them seem to be normally distributed on average. So what are your thoughts on this? Thank you.
So I guess the way I interpret this is that, again, the average looks like what happens when you ask people as if there is only one norm. But what that's concealing is that people actually believe there are multiple perspectives on that game, right? So this is just an aggregate of all these and 60 others that people respond, or people offer. So yes, on average, the social norm looks like this, but then you have to ask, so imagine you're making a decision. Are you thinking about people might punish you if you violate a norm, right? Are you going to get punished according to this norm, or are you going to get punished according to the norm that each person holds in their head, right? Does it matter who you're playing with? Or are you playing against the population, right? So you might, I think that's one reason that it's important to understand that distinction. Like, yes, the average looks the same, but it's concealing this underlying heterogeneity. And the fact that it's peaked in the middle, I think is just because egalitarianism is strong here. We're not sure if this one peaks in the middle just because this happens to be the actual empirical current marginal tax rate in the US for high earners, or because there's some appeal of the middle. So one of the things that we're thinking about doing is moving the empirical current tax rate to the side to see if it still peaks there, or if this is just like, I don't know. But yeah, I hope that answers your question.
Yeah. Thank you.
Great. Thank you so much, Masood. We have about 6 minutes, 3 more questions. Maybe we can rapid fire this. There's a question from Britt in the chat, and she's asking, wondering if you should compare what they think the pathway options are without incentivizing it to thinking about what others think. What would that say about the base case of norm influence?
So Britt, I'm not fully sure I understand what you mean with the question at the end. So I guess the idea that there are multiple normative perspectives on the same interaction is what we're trying to capture here. And so it's like, how many other ways can I imagine people looking at this? In what I'm showing you, they weren't actually incentivized anyway. So this is data where we said, behave as if you're being incentivized, in this way, but we didn't pay them for it because we were just piloting the method to make sure that it worked. So in some sense, I think these data answer that question empirically, but I'm not sure I understand what you mean by the base case of norm influence. Can you elaborate?
And Britt, please feel free to unmute if you'd like to elaborate on that.
Thanks. I'll try that. Sorry, it's 4 a.m. in Australia here, so I won't be turning the camera on. Apologies. Yes, I'm just trying, because it's such a complicated set of questions that you're trying to ask them to go through to get to the sort of understanding of what the norm is, and the ability to just simply plot what they think, the different ways that people do it without necessarily asking them to think. And I guess you've answered the question that they're not incentivized because they weren't actually paid for it at the end of the day. Just it seems complex is really kind of what I was saying, and whether people can kind of get through the complexity to get to the answer that you want. But I love the breadth of it. That was really all I was trying to say. Thanks.
Okay, well, I appreciate you getting up at 4 a.m. to come to this. That's very nice.
Absolutely. Thank you so much, Britt. There was a question from Don Ross who was trying to raise their hand. Don, please feel free to unmute yourself.
Thanks very much. Thanks for the interesting talk as always, as usual from you guys. When you get to actual incentivization, it seems to me one thing you should want to have your eye out for, something you need to control for, right? As the number of paths, as my set of paths I can specify through the space gets big, right? I get closer and closer. I converge on being closer to be able to place some bets basically on an increasingly dense range of possible normative responses. So if I'm risk averse, right, what I might do is just pick the most diffuse portfolio that I can, right? In terms of because obviously you're using all this and sort of entropy type relationships for your measures, right? So as I can spread my bets as you give me lots of paths to specify. Is that not right?
It's right, except that we arbitrarily capped them at drawing 10. It was basically
yeah, sure. But even
how many fit on the screen. And
right.
So even if they, exhaust those paths, they're getting whatever 10 over 243 is. It's a small percentage of the possible.
Sure, but I still have the option to make my selection of 10 either closer to one another or further apart in terms of their spread, right? So
okay, so we incentivize them to draw the paths exactly as others drew. If you draw a path that differs in one element from paths drawn by others, you get no probability. Any points you assign to that are wasted.
Okay, I see.
So basically we say draw all the paths and then make a histogram of how many people were each of those. And then the extent to which your histograms overlap with the average histogram from all the responses of everybody, that's the probability that you're going to get the prize. So anything that you draw that doesn't exactly match something that somebody else drew is wasted. And anything that you assign more weight to than other people assigned is wasted. Or if you don't assign as much weight as other people did.
Okay, that's important. That's important. Okay, I'll think more.
Yeah, so I went quickly through that, but this is how we explain it to the subjects. Maybe I'll leave it up there, but then take the other question. And if you have questions about it, I can come back.
Okay,
Great.
Thanks a lot. Yeah,
thank you.
Thank you for that, Don. I know we're coming up on time, but there was just one last question, so let's just get to it. It's a question from Hannah, and Hannah says, it's interesting to see that norms tighten across the panel. Why do you think that is? And is it that subjects are more familiar with the game and elicitation method?
I think so. You would expect if people found out that they differed from their peers that they should change their beliefs, right? Because it's a coordination game. So I do think there's some of that. Surprisingly, though they change, they don't actually get better at coordinating. So I don't have a great explanation for why that is, except it seems that they're changing simultaneously, and so they still miss each other in passing to some extent. Why they tighten? I think because imagine that you were in this thing, and then you talk to people about it afterwards, and you were really unsure the first time, probably what you would talk about with other people is a tighter norm than the one that you started with initially. So that's sort of my sneaking suspicion, is that when you're trying to hone in on what you ought to do, you would come up with tighter views than you would if you were thinking about it all by yourself. But that is mere speculation. I don't have,
Oh, no worries. Sorry.
No.
This
Okay, I thought I was getting kicked out of the recording for a second.
No, not at all.
Yeah. So that's just speculation. I don't, I would like to think more about it.
Great. Great. Thank you so much, Erik and Hannah, for that question. So guys, we're now up on time, but we just wanted to express our appreciation for everyone who was able to participate and ask questions today. Especially our great appreciation goes to Erik and Lucas for your presentations and your contributions. And then last but not least, we just want everyone to be aware that we have our next NoBeC talk taking place on Thursday, June 8th. It will be, the keynote speaker will be Professor Mario Maggioni from the Università Cattolica del Sacro Cuore. And yeah, in the meantime, thank you so much, everyone, and take care.
Thank you, everybody.